Amateur astronomers, get your telescopes double ready, because we're getting a look at 2 comets this month. I'm Eric Malikyte, and buckle up because a comet twice the size of Mount Everest just entered the inner solar system. Comet C 2017 K2 was discovered back in 2017. Back then, it was located around 16 AU from the Sun, so way beyond the orbit of Saturn. Interestingly enough, when Comet C 2017 was originally being studied, astronomers thought it had a radius of 99 kilometers, which would have been absolutely insane, though we've found a much larger comet since then. But it's also record-breaking because it's one of the only comets observed to become active at such a large distance from the Sun. As far as we've observed, most comets don't remain active beyond the orbit of Jupiter and Saturn. Comet Hale-Bopp is really the only other comet to give off similar activity at such a distance. It's also worthy to note that Hale-Bopp's nucleus is of a similar size as well. It's generally thought that when a comet gets nearer to our Sun, its heat causes the comet to shed material. This causes the comet to develop a large tail, and when the Sun's light catches it at just the right angle relative to our positions on Earth, we get treated to one hell of a show. We're not entirely sure why the comet was able to become active at such a large distance. Before we continue with the video, I just wanted you all to know that my book Solennier's Enigma Book 2, The Rise of Oriseth, is currently on sale for 99 cents. Book 1 is available for $2.99, so you can snag both on Kindle for $4. So if you dig Lovecraftian horror and dark fantasy, check it out now. Now, back to your regularly scheduled programming. But just because we haven't nailed down the exact reason for why C 2017 K2 is so active doesn't mean we don't have any ideas. Astronomers are going to be keeping a close eye on Comet C 2017 K2, and for good reason. Most comets that we've observed come from the Kuiper Belt, but not K2. No, this particular comet is thought to come from a region of space where the temperature is just 10 degrees above absolute zero. The Oort cloud, a shell of icy material containing both comets and dwarf planets like Eris, which orbits the Sun at 37 to 97 AU. For reference, absolute zero would be negative 273.15 degrees Celsius. That's really freaking cold. While Eris is thought to orbit the Sun in the inner Oort cloud, it's possible that Comet C 2017 K2 came from a place much further out. And it's for this reason that some scientists are proposing that Comet C 2017 K2 and other long-period comets that might hail from this region, get it? Because hail might contain forms of ice that would be completely unstable at higher temperatures. Essentially, this means that the ices contained inside this object would be subject to a much lower melting point than your average comet, which are usually composed of something known as amorphous ice. Yeah, there are actually more than 17 different types of ice. Just wait for my video on Ice 7. It's gonna blow your mind. This means that Comet C 2017 K2 has likely been on this journey for millions of years, and scientists believe it will give them a unique look at what our solar system might have looked like close to the time of its formation, billions of years ago. But you're probably here to find out if it's gonna hit the Earth, right? And as predictably as it is sad, the answer is no. Despite some of the clickbait headlines made by certain websites, which will remain nameless, Comet C 2017 K2 will not hit the Earth this month. I know, I was looking forward to the end of the world too. Bummer, right? Though if it did hit us, we'd be absolutely screwed because this thing is around 11 kilometers in diameter, twice the size of Mount Everest. Although that would be if it didn't break up and melt by the time it even reached the Earth. But just so you don't leave this video empty-handed, I endeavored to find out just how devastating such an impact would be for the Earth. I mean, look at this simulation I ran in Universe Sandbox. The Earth takes a serious beating. Although I had to approximate the speed of the comet as I wasn't able to find any data on that. This test was at 30 kilometers a second, though I imagine anything other than a gentle caress would be an issue. It is also worthy to note that I use Comet Shoemaker-Levy 9 and its composition as a basis for this simulation. So the mysterious ices that Comet K2 is supposedly composed of have not been taken into account. The simulations are all good and great, but when will we be able to see it for ourselves, and will we be able to observe it with the naked eye? July is shaping up to be an awesome month for comet gazing, with the coming of Comet 17P Holmes, which we did a video on that you absolutely need to check out. And Comet C 2017 K2 is going to be at its closest approach to Earth on July 14th. However, you're not going to be able to see this sucker with a naked eye. You will need a telescope. But there is some good news there, because amateur-friendly telescopes should be able to catch a glimpse of it just fine. You'll also want to point your telescopes to the constellation Ophiuchus, which is visible in the south and the northern hemisphere near nightfall, and sort of overhead in the southern hemisphere near mid-evening. That's all I've got for you today, but if you dug this content, be sure to do all that algorithmic jazz and like, comment, subscribe, ring that bell, join our Discord community, and share this video with someone who loves asteroids and comets. And hey, check out all those wonderful names. Thank you, patrons. I'm Eric Malikyte, and I'll see you next time, Space Cowboy.